In a world where conflicts are no longer just fought on land, sea, or air, but in a cyberspace, through autonomous systems and at hypersonic speeds, the question is no longer if technology will shape the future of warfare, but how fast we can align our innovations to stay ahead of the curve. Distinguished guests, esteemed leaders, and industry pioneers, on behalf of Synergia Foundation and BEL, I would like to welcome you all to this Thought Leadership Seminar on aligning emerging technologies to future conflicts at Aero India 2025. As we stand at the crossroads of technological evolution and strategic necessity, this seminar is part of Synergia's ongoing efforts to engage with key stakeholders, including representatives from the government and military, and enable military strategists and industry defense industries prepare for future challenges. On that note, I would like to invite our three important speakers for this morning, Mr. Toby Simon, Mr. Manoj Jain, and Lieutenant General G.A.V. Reddy on stage. I would like to invite Mrs. Neeti Pandit, General Manager, Strategic Planning, BEL, to felicitate our speakers. I would request you all to walk towards the lamp to do the lighting of the lamp, please. Kindly remove your shoes as a symbol of respect. To begin this morning's proceedings, I would like to invite Mr. Toby Simon, founder and president Synergia, Commissioner of the Global Commission on Internet Governance, and currently the co-chair of a global task force on transformative technologies for the G20 Summit. Mr. Simon is also a graduate of the Harvard Business School, research associate at the Massachusetts Institute of Technology, and international council member at the Belfer Center at Kennedy School, Harvard University, to deliver the welcome address on global futures and the future of conflicts.
Good morning, everyone. We have less time. We just have to cap it at 11 o'clock because the CDS will be coming in. So I'll try to speak in about 8 minutes. And the first is about why are we speaking about global futures? As the picture would indicate, this is a dystopian view of how the world might look like in the next, let's say, 30 years, 40 years. We don't know. That's looking at futures. So what is it that we are trying? Because at the end of it, as the moderator spoke in the beginning, we need to prepare for ourselves for a future war. And for doing that, we need to have strategic foresight. And what is foresight? So it's the idea of the future. It's a quote from 1937 of Keynes. The idea of the future being different from the present is so repugnant to our conventional modes of thought and behavior that most of us offer a great resistance to acting out in practice. So a lot of time we end up preparing for an old war. So foresight does not replace the future. It's a methodology that we adopt, a rigor that we practice to look at what are the patterns that can evolve, and from the patterns, how do you see how things are going to shape and change. Foresight is to future what memory is to past. An organizing yet selective principle, creating order in complexity. Just as memories, the future is therefore a discussion space where meaning is created, not an unpredictable set of events. Consequently, foresight is never about one future, but about shaping different futures. Foresight is much more about shaping the future than predicting it. So this is quickly, I'm just running you through 4 things that we use in our work. We call it, interestingly, one is known as the elephant and the black elephant, which is we call the known and the known. Highly likely but low in possibility in terms of reaction. The known unknown is the gray rhino, which is there is a foreseeable risk but low in its impact. The third is the black jellyfish, which is the unknown, the unexpected, and the underestimated. But these are the ones who are likely to create a lot of impact. And the last is the unknown, which we call the black swan. I mean, a lot of us have been reading about black swans, but it is extremely important when you do future gazing to look at the other 3. Now, what are global trends? We have mega trends, we have catalysts, we have game changers, we have outliers, and we have disruptors. I don't have time to go through it, but I'm sure all of you are clever. You understand what it is. The trends are those things which are likely to happen. Catalysts are lesser chance to happen, but if they happen, it increases the speed of change. Game changers are the big ones that we don't expect happening. Outliers are not at all thought about, and suddenly it happens. Probably 8 months back, who thought Trump would win an election in the US? But it became an outlier, and you see the impact all over the world post-January 20. Disruptors I have shared. So the mega trends is basically looking at individual empowerment. That's where the big thing is going. The individual human being is going to be very powerful in the future. The second is there is going to be a diffusion of power. Third is the demographic patterns are going to be, there will be a lot more instability. And the fourth is there is going to be a big nexus between food, water, and energy. What are the game changers? For us, it is crisis-prone global economy, the governance gap, the potential for increased conflict, wider scope of regional instability, impact of new technologies, and the role like big powers like United States or Russia or China will end up playing. Why is this important? Because all our conflicts and what we are going to do is going to be based on these different factors rather than what we look at from an inside perspective. What are the potential wars that we are going? There's one we call as stalled engines. In the most possible worst scenario says, the risks of interstate conflict increases. That is very true in regions like South Asia. We will continue to have more of, and maybe Latin America, Central America. We have fusion. This is the most possible, best case outcome. Genie out of the bottle, inequalities explode as some countries become big winners and others fail. This is more because of what happens in the technological race. Few countries try to consolidate everything faster. And then what are the drivers of change quickly? Global power competition, demographic pressures, climate change, technological advances, economic transformation, inequality. What are the tectonic shifts that we predict from now to 2030? Growth of the middle class. And we have to define what is the middle class, wider access to lethal and disruptive technologies, which is basically, we call it KMDs, knowledge-based weapons of mass destruction. It is not going to be the nuclear plant that is going to be more. It is going to be the guy who can make these small things in a lab at home. We have definite shifts of economic power to the east and the south. That is going to make a lot of change. You're seeing global alignment shifting, and the word mentioning of global south itself is becoming a little bit of a not so light world in many parts of the world now. Unprecedented widespread aging is going to be a huge problem. Urbanization, food and water pressures. What are the potential black swan events? Severe pandemics. That's going to be the biggest problem that we are going to face in terms of it being a showstopper, not even a game changer. We have much more rapid climate changes, the collapse of the euro and how it might collapse. A democratic or collapsed China is something that we are looking at if things play out in the future. A reformed Iran. Not to discount this, okay? Who thought Saudi Arabia would make so much of pivotal change in the last 10, 15 years? But the way you see things changing in Saudi Arabia, Iran could be, it's not something that we can rule out. You have a nuclear war or WMD or cyber attack, a solar geomagnetic storm, and a US disengagement from the world. So another sort of a dystopian picture. This is how we look at artificial intelligence now. It's a big ball rolling. We are afraid that we might lose our jobs, our careers, our lives. And this is it. We said, I don't know, I'm just keeping on running. Thank you very much.
Thank you, sir, for your insightful and compelling address. Your expertise has provided a profound foundation for today's discussion, shaping our understanding of the evolving global security landscape. I would like to invite Mrs. Neeti Pandit to hand over a token of our appreciation to Mr. Simon. Our second speaker is Mr. Manoj Jain, Chairman and Managing Director, Bharat Electronics Limited, BEL. He has completed his BE Electronics from REC Jaipur with gold medal and has an illustrious career spanning over 3 decades, making significant contributions to the field of research and development. Mr. Manoj Jain has received
We have to
various...
save time. It's okay. We'll start. No, we are running short of time, little bit. So I will start. Dear friends, good morning to all of you. So it's my great privilege to be given a chance to speak on emerging technologies, which is very close to my heart. Most of my time I spent on technology development. That's why the topic given to me also was nearer to that only. And in the context of this broader objective, which CDS and Reddy Saab will explain further, aligning technologies in future conflicts, how we will align them. Because technologies are keep changing, and now new and new technologies are coming. How we are aligning them for possible conflicts of future. And especially on the broad area of theater command for future combats. Because right now we have just done digitization of battle space. Then we have made it more automated now by various C4I programs. They are added AI as a flavor also is added to them. So they are not a just expert system. Now they are next level of expert system who gives a real advice, but still man in the middle is there for them. Next level is, can we integrate all of them and have a global view? And through operation also, theater mode of operation. So for that, what are the technological challenges? There are many of them. How we have to surpass them so that we can have quick solution for theater command. Although CDS sir will talk more closely about what is there in his mind about the theater command and how it should be there. But underlying technologies are also equally important. And so one is user perception and one is underlying technology. And we have to have a mix of both of them. So that is the idea which I wanted to briefly discuss about how to do it. You know now we have kinetic warfare and we have non-kinetic warfare. And we both have to merge together. Then only we can give a effective solution. The technologies, long-lasting list is there. Nowadays, the buzzword is AI, ML, and quantum computing. So these two are there, but in addition, anyway, there are lot many communication, space technologies, which we are going to use for giving a theater command, a real theater type of a feeling. So that definitely is there in our way. What we have to do is that our scientific community should develop these technologies and mature them at the earliest for this type of operation. This type of concept of operation which will be bit different from the present way of operation. How we are understanding and adapting our technologies for this. We have to go a long way in doing these things. The technologies anyway, these non-kinetic warfare which are very, very important, the direct energy weapons which are there. You have seen laser-related weapons, which anyway our next speaker will talk much more about that, where we are and what we are, but how to seamlessly integrate these type of weapons and sensors for the type of conflict which we are going to face now. Because you have seen kinetic warfare have limited role in future. Because you can't have when thousands of like the missiles are coming, you can't neutralize them by again thousands of counter missiles. You have to have a reusable type of warfare. So our direct energy weapons comes in that domain where with one laser itself you can shoot down thousands of missiles over a period of time, and that will be more cost effective also. So how we are going to interface these type of new warfare technologies in the overall scenario, and who will operate them? Whether it will be operated by like army only will operate some type of equipments or weapons, and navy by some, it may not be like that. Even from a naval ship itself, you can neutralize so many things because these warfares are of different variety and they can be mounted on a small ship also. So those type of changes are going to happen. So these things will be there. Anyway, we have weapons, hypersonic weapons, so many things are there in this. Cognitive technologies are coming now. More and more of cognition is coming. How we are going to add them is a really challenge. Knowing the importance of these all emerging technologies, BEL also aligned its R&D programs in a way that all our ongoing research programs are now trying to mature these technologies and see that how they can interface and finally integrated in this theater command type of a C4I solution. So those solution related underlying technologies, we have invested a lot and we are in that maturing process. The two technologies which will change this, one is this quantum technology, quantum computing, Because now once you have a theater command, the processing power requirement may not be held only by the GPU type of resources. It may require much more faster computing. So quantum computers definitely is going to change how we are going to process lot of information and give valuable expert opinion in a fraction of second. And then AI and cognition. So these two technologies are going to do too many things. We will do some predictive analysis of the data. What is going to happen, we should know beforehand. And then those type of logics also are inbuilt in the system, so the decisions are taken faster. Startup community definitely is there to help us in developing these cutting edge technologies. They are doing, but they don't have the overall full context. The context is held by users or big companies like BEL and these startups who are developing these niche technologies. How to imbibe all of them and provide an integrated solution has to be seen. So there is a role to play by all of us to develop this cutting edge military solution related to theater command. So I feel all of us have to work together, then only a state-of-the-art solution can be made. And definitely India, we want to be ahead of others for this type of a theater command perspective. That is all I wanted to just briefly touch upon. Time is short. I want to wind up my solution, my speech. Thank you. Jai Hind.
Thank you, sir. On account of time, I would like to introduce our next speaker, Lieutenant General G.A.V. Reddy, Ati Vishis Seva Medal, Shaurya Chakra.
Good morning, ladies and gentlemen. While I was wondering, looking at the audience here, would you be interested to know what is theaterization? And if so, why is it so interesting for you to know about the theater command concept? Well, I feel there are stakeholders in this hall, from military, from technological background, from corporate and business background. So there is a linkage between what Mr. Toby Simon said about global futures and the contours of the future conflicts. Next, what CMD BEL, Mr. Manoj Jain, spoke about the role of the emerging technologies in these future conflicts. And then the net effect of that is that a new concept called theater command, or often referred to as theaterization. It's a strategic transformative initiative in the history of Indian military. It's a pivotal moment, if I may say, because in the world, only 5 nations have taken the risk of adopting this concept of theaterization. I say risk because it has got tremendous challenges. The first challenge being arriving at the consensus amongst the various stakeholders, that is Army, Air Force, and Navy, because all of them have their own doctrines and methods of operating. But I would say still India has taken this leap and has started working on this theaterization concept. Why? It has got 2 offspins. The first one is for the armed forces, that is for the security of the nation. And the second one, which is more probably interesting for this audience here, is the enormous opportunities that it will offer to the Indian indigenization process, or the self-reliance, or also called as Atmanirbharata. So let me first talk about the operational spin-off and the advantages of concept of theaterization. It's at the beginning is considered as a strategic deterrence. When we say strategic deterrence, the potential adversaries, you know who are they, whether it is across the northern borders or western borders, or could be from maritime domain. They know what India can deliver at the point of conflict, at the point of time. So that's why I say is a strategic deterrence to the potential adversaries. The second one is that it also comes with the strategic regional defense. That means a theater command will appreciate the specific vulnerabilities, the risk, the kind of threats that he is going to face, and then he will be so much well poised, well prepared to deal with the theater specific vulnerabilities, risks, and the threats. So it's one commander for one theater. What does it further translate to? It means faster, agile, and swift actions. Doesn't it unnerve the adversary? Obviously, yes. Also, we have the other advantage of adopting and applying emerging technologies in that theater command by the theater commander across all domains, across all three services. That is a tremendous advantage. All the emerging technology solutions that you people would be offering to the armed forces, it is not going to be piecemeal service-wise. It is going to be command, theater command. And the theater commander will be able to appreciate what is essential in his theater and utilize those emerging technologies proactively. Also, this streamlines the command structure itself. Imagine if there are 3 bosses in an organization, obviously your loyalties, your efficiency will also be divided. But if there is only one point contact of decision making, he will also be fed with all the inputs that he needs to make that considered decision. The decisions will be very considered decisions, very rounded decisions, and it will be very faster also. So that is the kind of command system that we'll have across all the 3 services, one unified commander. It also offers comprehensive capability development. That theater commander who is responsible for a particular theater would know what it requires to capability enhance or build up the capacities. He would work hard to get the resources optimally utilized, and then he will prepare the kind of battlefield that he is going to face. Lastly, we often talk of civil-military cooperation. When there is one unified commander or the theater commander, you will be able to interact very meaningfully with the civilian counterpart, whether it is the state chief secretary or the state police chief, to identify the threats to the civil infrastructures, which is equally important to ensure during the times of conflict, to enhance our seamless flow of logistics and support services. Now, this having said about the spin-off effect of the theater command for the armed forces, what is it for the indigenous defense industries? When I say industries, encompasses startups, MSMEs, and the well-established large-scale defense industries. The first benefit is that you will have a consolidated requirement projected to the manufacturers or the industries by the user. Imagine vis-a-vis the existing system, you have to go to 3 directorates of the 3 services. Each of them will have systems different from the other, and then the evaluation process is so long that sometimes the user doesn't get what he needs, and then the provider, the manufacturer, doesn't deliver at times what is required critically by the user. So the best advantage is consolidated requirement. And also it comes with a large requirement, which is an attractive offer to any manufacturer who would invest in producing those products or technologies or platforms. The third impact is that defense ecosystem in the country gets a major fillip. It's an impetus given within the country for having many more the defense corridors, where there will be encouragement by both the state government, the central government, and the armed forces to develop what the armed forces need to face the future conflicts. I spoke of the cutting edge technologies being adopted and applied together. Exactly that's what the theater commander would be able to offer to the manufacturers and the suppliers. What is his requirement, the specific requirement of the emerging technology that he needs to fight his battle in his own turf. And the other spin-offs, it will also encourage collaborations, international collaborations in forms of joint ventures, co-production, and also it will also encourage the joint R&D. Within India, you get the best of technologies to work together and thereby enhancing your potential as well. And the last one is the impetus given to the private sector. So with all this, I would conclude by saying that theatre command or the theatrization is a strategic transformative initiative, and it is a pivotal moment, as I said, in the history of Indian Armed Forces, which will have great impact in the years to come. And with that, I conclude, and now I hand over to the MC. Thank you. Jai Hind.
Thank you, sir. I would like to invite Ms. Amrita Shetty, COO, Synergia Foundation, to hand over a token of appreciation to Mr. Manoj Jain and Lieutenant General G.A.V. Reddy. It is a privilege to welcome General Anil Chauhan, Chief of Defence Staff, Government of India, a distinguished leader decorated with the Param Vishis Seva Medal, Uttam Yudh Seva Medal, Ati Vishis Seva Medal, Vishis Seva Medal, Sena Medal. With an illustrious career spanning over 4 decades, General Anil Chauhan has held numerous command, staff, and strategic appointments, playing a pivotal role in shaping India's defense landscape. His extensive experience in counter-insurgency operations in Jammu and Kashmir and the Northeast India underscores his deep expertise in national security and military strategy. It's an honor to have you with us here today, sir. Please join me in inviting the CDS on stage to address the gathering. I'd also like to invite Mr. Manoj Jain and Mr. Toby Simon also.
Managing Director of BEL, Shri Jain, Toby Simon of Synergia Foundation, distinguished guests, ladies and gentlemen. It's a matter of great honor for me to be here and to speak to you and share my thoughts on this very interesting subject of aligning technology to future conflicts. You know, this particular subject is of great interest to me as a military officer, and in fact, it should be of great interest to everyone who professes the profession of arms. It's because the profession of arms is slightly different from others. In other professions, you practice it on a daily basis. If you're a lawyer, you're practicing law at the bar. If you're an architect, you're actually drawing. If you're a doctor, you're practicing medicine. But the nation doesn't go to war every day. So what do armed forces officers do? They actually think about the future. And they train themselves, equip themselves, think of technologies, think of tactics to prepare for that future war. This, I think, is important, and this distinguishes us from other professions. And why this is important, and why do we invest so much of time thinking about the future and future warfare is, we all know that there are no runners-up in war. There is only one who wins, and the second party is vanquished. And the victory or defeat in any war is actually can be catastrophic. So that's why we prepare for war with the sole aim of winning it. There can be two perspectives to define the relationship between technology or combat, or say tactics. One could be that technology drives tactics. That could be one. And the other could be actually that tactics drives technology. That's your requirement, actually. So there are two conflicting kind of perspectives. So it's like that chicken and egg story. We really do not know which drives what. I'll try and kind of clarify a bit my thoughts onto it. First is about tactics that drives technology. Historically, a man has developed technology to provide himself edge in battlefield. And technology will provide him better protection, better mobility, and better firepower. Firepower in terms of lethality, range, precision, etc. So all this is the job of technology because he wants to do this, to protect himself, to be better, have better mobility, and have better firepower. So you can take examples like body armor today, what we're talking about, BPJs. Ever since warfare has evolved, it's been there, the need for protection. So it was in earlier days, leather actually, probably, or then it was steel armor, which people used to put on, or chain mail, which was being put on by knights. But today you have bulletproof jackets because the things have changed, but the need for protection remains the same. So now you have Kevlar or maybe composites actually trying to do the same thing, which thousands of years ago did that to a normal man who was fighting with swords and spears. So there's one end. On the other end, if you see tanks and aircrafts, which have been developed in later part as part of modern warfare. So you have today, there's a talk about 6th generation aircrafts and 5th generation aircrafts, aircraft being the same. So technology is always evolving to do that particular job which the tactician requires it to do. So it provides is used to provide you more power, that's maneuver capability, it maximizes endurance, radius of action increases, it's more lethal, and it's more efficient. All these kind of technologies which make a system lighter, better, more efficient, faster, are kind of sustaining technologies that we have understood. So this sustains that thing because the need is always there, so you keep improving upon these technologies. And so technologies like, material technology, complex alloys, novel materials, advanced manufacturing and all, these are the ones which come in. Then there are some dual-use technologies. Same technology has application in civil as well as military field. Examples are communication technology, detection, radars, sensors. So they provide you some kind of a thing beyond visual range. Then you have your computational kind of abilities, that's your computers. Since this particular technology, dual use, is not been actually made for combat, so it has a great impact on combat. So this is where actually technology is driving kind of combat. And for this, the armed forces will have to be really very, very adaptable. They'll have to adjust things and they'll have to accommodate this kind of technology in their fighting systems. And as men, we have to be very innovative, inventive, and imaginative. So when we talk about the shift from maneuver warfare to net-centric warfare is because of the dual-use technologies like ICT and your ISR technologies which went about. So it has introduced new things like situational awareness and battlefield transparency. When we talk about net-centric warfare, it is about information superiority, and focus is on actually information dominance. So to do this, one has to understand networks actually as verbs and not as nouns. Because if you consider a network as a noun, it is quite sterile. it is quite passive and inert. When you think is that as a verb, then actually you are exploiting it to use warfare. Then let me talk about now emerging technologies. The application of emerging technologies in combat is still, some distance away. We know that these technologies are going to influence warfare in future, but what will be the exact shape, we may not be able to understand fully. Say, we talk about, say, artificial intelligence, or we're talking about today 6th generation aircrafts. How are they going to actually change warfare in the air by having MUMT, that is your manned and unmanned kind of a teaming, or you have artificial intelligence which will drive your, make you actually transform from net-centric warfare to data-centric or more intelligent kind of warfare. So where you'll have dominance of decision-making actually. So this is one area where we are still far away. We know that technology is there, but what kind of influence it will have on battle and warfare is slightly away. In this actually, both things are true. That means technology can drive tactics also in this, as well as tactics can derive technology in this emerging technologies. So that's the third postulate which I would say, which I started with. So we can modify, as I said, tactics and technology. And the simple example which I gave you was data-centric warfare, which is all about superiority in decisions. That is, you're taking faster and better decisions than your adversary. And then, of course, we also talk about sometimes as disruptive kind of technologies. So disruptive technologies, the effects of such technologies are disruptive and disproportionate to the effort that is being put. So this normally happens when one or two technologies actually combine together, and then you don't understand how it will pan out. So long back in the middle of 19th century or before modern warfare evolved, technologies like telegraph and steam engine, that revolutionized warfare in a big manner. Because before that, all warfare used to be fought on a single battlefield, all. Every battlefield which you see, from Haldi Ghati to Palasi, every battlefield was on single battlefield. This provided you mobility. You could mobilize faster, you could mobilize from one theater to other. It introduced the concept of theaters. It introduced the concept of fronts. You could actually fight you could command the battle by being a distance away. And same thing, when it was translated to steam engines and to submarine cables, would allow you to project power far beyond your shores, which the Western powers actually utilized. So these are having disruptive kind of effects. And in today's context, we can talk about, say, quantum sensing. That will give you freedom actually from satellite-based navigation systems. And with pinpoint accuracy at thousands of miles. Along with this, means if you do this along with hypersonics, then those kind of systems become undetectable. You could also do artificial intelligence with autonomous weapons that will again change the face of warfare. Now let me talk about warfare. That's the second part of the talk. That's future warfare and aligning technologies to it. We all know that warfare is a complex business, and predicting future is difficult, but predicting future warfare is even more perilous, to say the least. But then I'll try to simplify things as to how can we do it. So I'll break it down into three small parts. First is I'll talk about the nature of battlefield, how it is changing. I'll talk about nature of combat itself, how that is changing. And then I'll talk about the types of war that we might see in future. So the type of battlefield, we all know that warfare actually all evolved on land and then graduated onto the maritime domain and then also evolved into the air domain. And with every new domain, it had an influence on the preceding domain, disproportionate kind of an effect. Now, what we are saying is, I'll talk about the new domains later, but within these domains itself, there's a huge amount of change. In the land domain, because of population growth and ultimately the aim of any war is to impose will on the adversary and the enemy. And these population centers actually become hotbeds of conflict and not vast areas. So warfare may evolve into more of urban kind of an warfare, which you're seeing today in, say, Gaza. And like in Gaza itself, you can say it's also subterranean. So land also, you'll find subterranean warfare evolving because people want to escape. People have silos. Americans had this, Russians had this. You build silos for your missiles. So you're going actually underground. That is one thing. And warfare is going to transform itself into urban, complex terrain and urban warfare. As far as the maritime domain is concerned, so apart from surface, from where it actually evolved, it is now going underwater and almost up to seabed. It's going to seabed because most of your communication cable, the internet actually runs through those submarine cables, and you have the seabed full of minerals and materials which may be actually required for the future. So again, this maritime domain is going down right up to the underwater domain and to the seabed domain. And as far as the air space is concerned, we're seeing its expansion into near space. That is almost about touching to the edge of 90 or 100 kilometers because of what we've seen the Chinese flying those high-altitude balloons with surveillance cameras which can't be targeted by any missiles. Or you think of HAPS, high-altitude pseudo-satellites which are emerging. We're talking about hypersonics, so which are operating at that particular altitude. So we'll have to combine normal airspace with near space to be combat ready in future. So within these three domains, you'll find a lot of changes, apart from the domains of cyber, space, and electromagnetic spectrum. So space is not only cis Earth, but we're talking about lunar in probably as time passes by. So we need to align actually technologies to fight in these new domains and these existing domains which are getting more and more complex. So that's where technology will help us. And now let's talk about nature of combat, how combat is changing because of technology. There could be huge trends, but I'll just mention about three important trends. First is about non-contact warfare. Traditionally, we always in warfare, we have thought about reducing the danger to the combatants actually. So we try to always put distance between two of them. So from a sword, you came onto a pike or a spear, then you came into a matchlock pistol, then to a rifle, and then to an artillery gun. So today you have systems which are actually targeting things beyond visual range. So you're targeting tactical, operational, and strategic targets at large amount of ranges. The battle space actually then expands. And as I said, that within those traditional domains it is expanded. So you have a huge battle space in which to carry out operations tomorrow. So it becomes it becomes very, very complex. Then you have this advent of unmanned platforms. That is one area where warfare is proceeding to because of advancements in robotics, exoskeletal, where actually you provide human endurance becomes better. And this is leading to manned and unmanned teaming. That's the very essence of sixth generation aircraft, that it should be kind of a flying command and control center which is able to control 2 or 3 platforms, aerial platforms of similar type, or of, say, UCAVs or swarm drones, etc. So that is one area which is going on. And of course, it will lead on to automation. If that happens, that will be the ultimate. So warfare, which for generations have been between two human beings. It was always been like that. All duels had been between two human beings. You would have been armed better than the other one. You could have been better protected. You could have had better mobility. You could be on a horse, other one could be on a better horse or on an elephant. But the combat was essentially between two human beings. You could be today on a light combat helicopter, and other gentlemen could be on a tank or an aircraft. But essentially it was between two humans. But today we are at the verge of defining this. Tomorrow's combat may be between humans and machines. And later on it could be between machines and machines. It could be autonomous. Warfare is also going to become multi-domain. That means in one war itself, we'll have to fight in 2 or 3 domains actually. I just told you about complexity of land, how it is going subterranean and urban and very complex terrain. The maritime domain, I told you where it is proceeding to air space, and the new domains of warfare itself. So this is becoming more and more complex. For this, what we require to build technology is for cross-domain operations, that from Navy we should be able to influence warfare on sea and undersea from land, and similarly and vice versa. So cross-domain operations, cross-domain command, I should be able to, from sea, able to command some of the assets which are on land, so missiles, etc., air defense systems. If that is not possible, then you will not be able to fight a multi-domain kind of an operation. We are also talking about the battlefield, the war becoming more and more intelligent. It's becoming intelligent because of 3 or 4 trends. That is one, digitization of the battlefield, networking. That means you're networking terrestrial, aerial, and satellite networks together to get a very composite picture. You have a large amount of data, and from sensors today, which are ubiquitous. Today, that means the man-made sensors, probably I keep quoting this, The population of ours is about 8 billion world. 8 billion? Yeah. So we have 16 billion sensors actually, man-made, God-made, natural sensors. But your man-made sensors are today have overtaken the number of sensors because all mobile cameras, everyone has a mobile, you have a camera into it. All computers, laptop, iPads have cameras. You have cameras everywhere. There will be 10 cameras in this particular room, and there are right up to satellites. So man-made sensors. So the amount of data which you are generating is humongous actually, because of this ubiquitousness of this data. So a large amount of data processing will lead to more intelligent kind of warfare. And when we put artificial intelligence and machine learning into it, it will help you to take faster, better, informed decisions. And this is what I said was leading you to a data-centric warfare or more intelligent sort of warfare. So these are the trends in the various domains of warfare I've spoken about, the nature of conflict I've spoken about, and how technology must get aligned towards this to help you fight. Now let me talk about the very type of wars itself, or the nature of war itself. And for talking on this means, in fact, no talk on warfare can get complete without talking about Clausewitz and quoting him. So I'll have to quote Clausewitz while talking about the types of warfare. Remember, he said that war is a continuation of policy by other means. That's a famous statement of his. If you read through the statement, there are two very important derivatives from this. It actually, the first is warfare is a finite kind of an entity. That means there's something where policy ends or politics end, then war starts. And when war ends, again negotiation starts and politics starts again. So warfare itself is a definitive or firm kind of an entity. That is one. When you say warfare is a continuation of policy by other means. And second is that to enter war is always a rational decision. There are two important things. So it's a definitive finite entity, and there's a rational decision making in war. Because it's after thought that you decided to enter into war and leave politics behind. But what's happening now is warfare on one end, like terrorism actually, is irrational by its nature. And it is such that it continues, it perpetuates. So there is no definite end and no definite start to terrorism. So that is one important change, which is very different from Clausewitzian wars. The second is gray zone warfare, which is also played out below the threshold of actual war and conflict, and because of the danger of actually escalation. And this itself creates protected kind of conflicts. While I said that the nature of warfare would lead to, say, gray zone warfare or terrorism, which are slightly different from Clausewitzian wars, which had a definite end state and were a rational kind of a decision, but that doesn't mean that conventional conflict, which we all used to or we prepare for, that's going away. So all this becomes a kind of a continuous continuum, right from competition, crisis, combat, and war. So this is a kind of a continuous composition. It's a complex continuum, and example of this could be actually a good example could be a Gaza war. So what Israel is fighting with Hamas is a conventional conflict, full-scale conventional conflict. What's happening with Houthis is less than conventional conflict. And what is happening with Iran is even slightly different. So all three are happening at the same moment and same kind of time. So warfare by very nature itself is getting more complex, other than the other complexities which I spoke to you about. So aligning technologies with the future warfare is not the only answer. There is only part of the answer to actually get that aim of winning a warfare. You will have to evolve new concepts, new doctrines. You will have to create new organizations for such kind of a combat, and you'll have to build a new culture and processes if you have to win. Technologies will only provide some part of it. That's all I had to say, gentlemen. Thank you very much.
Thank you, sir. Would you be open to taking a few questions? Yeah. Open up to the audience right now if anyone has a question or two, so we can wrap it up quickly.
Yeah, I'm so glad.
Okay,
Otherwise,
the mics are on.
there could be only two options. Either everyone's understood whatever I said, or no one's understood what I said.
The requirements
About?
and about the requirements and the technology, or the tactics and the technology
Yeah.
being interdependent on each other. We also need to touch upon the fact that the delivery time of the technology that we are aiming for takes a lot of time in the present context, particularly the defining of requirements, their finalization, understanding by the developer designer, and then giving you the product. I think I've been always saying this, that we need to now develop a product in conjunction with the developer or designer, so that the time lost between your defining the requirements and thereafter designing the product is cut down drastically. And while the product is getting developed, it is also getting checked by the user, and then your relevant changes are made, rather than doing it at the end and then ending up with a lot of time being spent on that.
Thank you. Thank you. So, I would rather modify your statement to say that when we're chasing a product or a platform, then it takes time, because we are kind of understanding the GSQRs of a product which by and large is already available. This particular process, if we follow, which we are currently following, ab initio will be behind, because that particular product or platform exists. What I told about emerging technologies, you should take a cue from there. So how you're going to use technology to fight? You imagine that, and what all technologies will you require to support that? Some may exist, some may you have to modify, some may you may have to develop, and get an integrated kind of a complex. So you're not looking at one platform, you're looking at how you want to fight at tactical operational level. So that, I think, is important for the future. And in this, what is important is we'll have to change our processes, because our processes of ours are actually made to acquire a particular product. And as I said, when you're acquiring a product, you're actually behind 5 or 10 years, because that product already exists. So you're not investing in technology. So we'll have to change this system in which we are able to invest in ideas, invest in technology, in case we want to compete with the West, or arrive, what I said is fourth or third revolution in military affairs, in line with the West and not behind them.
Just one more question.
Sir, you covered so many war scenario. So theater commands give to all these unified pictures, or it's like a cyber warfare you covered, asymmetric warfare you covered, conventional warfare you covered. So we need all to be integrated with the technology solution. All this, or it is going to the only jointness for this.
Yeah, please sit. Thank you. So, towards my concluding remarks, I did mention that technology itself, aligning technology by itself, may not lead you to win wars and conflicts. You'll have to carry out doctrinal, conceptual changes. And when I said organizational changes, I actually had this in mind. Theta command models we'll have to adopt, which is nothing but trying to separate out force generation from force application. So presently, both these capabilities or both these responsibilities rest with one gentleman of all the three services. We are trying to separate this out and create commands in which only operational aspects of maritime, air, and land would be the responsibility of one single commander. This way, he will be able to focus more on the aspects of warfare which I talked about, the changing nature of warfare and conflict. Because presently, we are actually dividing our time in both, and with suboptimal results on both sides. That is force generation also and force application. Yeah. Thank you.
Thank you, sir. On behalf of Synergia and BEL, we would like to take our time to thank you for sharing your thoughts with us today. We would also like to request Mr. Manoj Jain to felicitate the CDS with a token of our appreciation. And I would like to request Mr. Toby Simon to present a token of our appreciation to the CDS. Before we begin with our panel discussions for this morning, we have two videos that we would like to play. Can we have the first video from BEL, please? Can we have the next video, please? Thank you. This brings us to the first panel session for this morning on emerging technologies. We are honored to have a distinguished panel of experts with us, and please join me in welcoming them to the stage. Our first panelist is Professor Gopalan Jagdish. Professor Gopalan Jagdish is the head of Department Aerospace Engineering at the Indian Institute of Science, Bangalore. Our second panelist is Dr. Subba Rao, the founder and chairman and MD of Anand Technologies. And our third panelist is Rear Admiral Ajit Tekapat, DG Weapons and Electronic Systems Engineering Establishment. Can we have the speakers on stage, please? Professor Gopal Jagdish will also be the moderator for this session. Over to you, sir.
Lovely. Good morning, ladies and gentlemen. Such an honor to participate in this program. And I think what we will do in this panel is probably give some broad overview on what I really think is future conflict and how the conflict science itself is evolving. And what is it that we, as common people who are involved in development of technology, would really like to do? Before I really look at this, a very brief presentation, I'll probably make a brief remark for about 8 minutes to 10 minutes, and then invite my fellow panelists to make their comments, and probably we can have some kind of a dialogue. I think we all hear about words like science, engineering, and technology in a very casual sense. To me, science is all about understanding nature, and in some sense, the Lord Brahma represents science. And that is also the reason why there are no temples to Brahma, probably other than 1 or 2 in the entire country. Because society at large will never understand what is actually science. Engineering is all about asking the question, why not? And in technology, we don't want to ask any question. We want it to work all the time. So in some sense, the classical Hindu mythology of Srishti, Sthiti, Laya, represented by Brahma, Vishnu, Maheshwara, probably evolves the whole creation. Today we are living in a very complex world where while we were recovering from the wave of Industry 4.0, already we are talking about Industry 5.0, where we are moving away from mass production to mass personalization. Everybody wants everything for their own self. It is in this context, the future conflicts probably is going to hinge upon 3 important things. The kind of information you have, the kind of resources you have, and the kind of knowledge you can derive out of the information. It is in this scenario, one has to look at what kind of threats we are going to have in the coming future. So we are very happy to have a very nice panelist today, and I have just tried to depict what is it that this panel would do at the end of half an hour. Today there is a space for defense, and we also need defense for space. General was talking about what is happening below the sea, but ladies and gentlemen, the whole world has become a single entity today. And probably it has taken from Homo sapien to become the current, from amoeba to Homo sapien about 35 million years ago. But then today it just looks like a child has just woken up. And I am from academia, like a child who is amused by the nature. And then here we have a technologist who is actually looking at this entire universe as Ananta. From Anand Technologies, Dr. Subba Rao. And we are now today connected to the whole world. Very recently, we received a signal from an exoplanet, a radio wave which came from nowhere. And we have Admiral Ajit, who is an expert on communication. How do we really look at merging hardware, software, and trying to win, future war? So I would like to just touch upon few things here so that you will really highlight one particular disruptive technology that I believe is going to hit us badly, namely hypersonic technology. And during the course of this 10 minutes, I will also highlight how are we all connected. No longer we can look at working or doing anything in isolation. Probably recently, Government of India formed a committee under my chairmanship to look at a SWOT analysis for space and defense technologies. Of course, when you do a SWOT analysis, the options are plenty. But then what we have tried to do here is to identify a concerned person who can actually translate a vision into actual action. While we all talk about the bird's eye view very well in many forums, it is the worm's eye view that often makes us very difficult to implement something we think is required for the future. In all of this, few things are becoming very clear today. Our ability to really look at future communication platform, especially with reference to the AI-enabled chip. For example, the companies like ASML have a 2 nanometer technologies, and we do not have access to any of them. Quantum processors are becoming a common order of the day. Maybe quantum technologies and the communication link, so many things may change, but our real ability on the hardware and the material is going to actually hit us very badly in the near future. How do we really look at building 2 nanometer chip, and how the AI-enabled platform with enough edge intelligence is going to change the entire scenario of hardware and software is going to become very important. I would like to highlight this based on one technology because hypersonics is one area where you can actually talk about quite a few things. Of course, where you will really understand, today we are talking about system of systems. So there is no longer something called civil, mechanical, electrical, electronics. Everything is seamlessly merging on something which is going to become a surprise. Hypersonic refers to flying objects above Mach 4 or Mach 5. Today, every country in the world is actually chasing this technology. They do believe anybody who can build a successful scramjet engine is going to rule the world for next to 350 years ago. 1873, when Stephenson ran the first engine from Newcastle to Leeds, it actually traveled at 3 miles per hour. And at that time, if you look at history, people said you shouldn't travel so fast. Probably our brain will explode, chicken will not hatch. These are all documented. Today, we are talking about 6,000 kilometers per hour. 3 miles per hour, 1873, probably was comparable to Bangalore traffic, 10 kilometers per hour. But a man who has actually looked at a very small speed was very detrimental, maybe about 2 decades, 2 centuries back. Today is talking about reaching anywhere in the world in 1.5 hours. So you are going to be in for big trouble if you are going to have successful flying objects at these kind of speed. We all thought that this is just a myth, until recently in the January, when Pentagon for the first time has acknowledged in public that Chinese actually had a hypersonic glide vehicle which went around the world, 44,000 kilometers, 100 odd minutes it was actually in flight. And this is publicly acknowledged today, which means you can't even detect, no radar can detect, and it can actually come and hit you at any part of the world at their desired level. They have also actually a scenario where air-launched hypersonic missiles also is a reality. That means you have flying systems which are going to fly at 6,000 kilometers per hour. Bangalore to Delhi in 15 minutes. Tokyo to New York in 2 hours. Anywhere in the world in 1.5 hours appears to be the disruption that future conflict would like to actually impact anyone who has a technology like this. Chinese have. So this is something that we need to seriously look at. If you look at the missile system, many of these things, hypersonic systems would fly, glide vehicle would happen at altitude of 110 kilometers, but your actual scramjet stuff is going to happen in altitudes of 20 to 25 kilometers. These engines, the so-called scramjet engines, they do not have any rotating parts. So it's a completely new ball game that you're actually talking about. People are trying to build. I thought only hypersonics would be only military, probably about 10 years ago, until recently in January when we had the world's largest SciTech, Japanese are building a hypersonic aircraft at Mach 5. People have started looking at using hydrogen fuel to go for cargo as well as transport aircraft. There are private companies like Destinus which have raised millions of dollars just to build an unmanned hypersonic vehicle. So this is here to stay. So this is a technology which is going to be for future disruption, both in the war field as well as for logistic support. And GE actually has launched a vehicle in this direction. Of course, this is a small laboratory that we have, Indian Institute of Science. When we started working in this area 25 years ago, We hardly had any project support as usual, but academicians are like dreamers. We thought one day these things would become very important. Today I'm glad that these laboratories are acting like springboards for the nation to build several technologies, including hypersonics. Of course, there was a challenge in all of this, but then Dr. Kalam was a visionary. In 2010, he actually said that you need a hypersonic center of excellence, and he handed over a check for 5 crores to our director when we had not actually proposed any proposals. Probably such kind of thought leadership to look at future R&D is what is required for the country. Whether organizations like BEL or HAL should actually look at R&D and intellectual capital as a future investment rather than delivering product, because Shiva is both the creator as well as the destroyer. Today's product will become tomorrow's obsolete system which nobody would like to use. Scientific base and scientific intellectual capital is going to be the key if India is looking at catching up with the emerging technologies, in my view. Of course, I am tempted to put this slide because we have both Subbarao as well as Ajit here in the audience. People thought electronics is something like a subsystem, then I will integrate it with another system and then it will become a weapon. But today we are talking about integration of avionics with hypersonics right at the design stage. Because when these vehicles re-enter the atmosphere, you can't actually detect them. But people are looking at a constellation of satellites which actually provide a continuous support to these kind of systems, which means the amount of edge intelligence you put on an electronic chip is actually decided before you even look at a weapon. So constellation of satellites, that's why I said maybe space for defense and defense for space is actually becoming very vital in hypersonics. Maybe it is a need of the hour where we look at for the entire theaterization program that we are talking about, what Toby talked about. Everything is getting a single entity today. And if you want to do that, the only way is look at directorates for these emerging disruptive technologies. Services should start actually owning up new technologies rather than being only the user of technology. A golden triangle that people talk about in entrepreneurship comprises of capital, customers, and competence. But today I believe customers also should need competence and capital. No longer services can simply say, I will absorb technology. You develop technology and I will come back and use it maybe after 5 years. You will have to decide about taking the ownership right today. US is a very good example where they have a hypersonic transition office in Washington, DC. Colonel Tucker heads the entire Wright-Patterson lab. He comes out and says what my country should do in hypersonics. Probably it is high time. Services define, I need a weapon like this in 5 years. Can everybody come together, including academia, startup, big industries, innovators, general public, so that as a nation we will be able to do something quite substantial. It is in this context, I just put a roadmap, but I would stop here with few things that I want our own panelists as well as others to ponder on. Number one, we are actually looking at Industry 5.0 wave, where we have moved away from mass production to mass customization. While we continue to build technologies for the nation, we also should not lose track of the foundational science and the intellectual capital. And that doesn't happen overnight. So how do you merge academia in this entire exercise? While we chase technology, we also should make sure that the foundational science is very strong so that we can become truly Atmanirbhar in that sense. Maybe having said that, I said services should own up the technologies, because if you don't own up, you have a lot of people on the scientific career whom you send them to higher institutes of learning to do their masters. But after that, they just merge away in that huge sea of combat. Probably technical people also trying to have a career progression so that Navy, Army, and Air Force will say, this is what I need in the next 5 years. Take the lead in bringing the whole country together, work on a mission mode, rather than trying to do bits and pieces and then try to assemble. Communication is going to become extremely challenging and key, because communication is not what I speak, it is what you people understand. Having said that, we have a communication expert here in Rear Admiral Ajit, who has been doing some phenomenal work for Navy in trying to really say, how do you integrate various modules on several platforms? He is the Director General of an Office of Navy, which actually coordinates this activity. You probably would not see him in many forums. We are very glad that, Admiral, you are here. May I invite you to share your thoughts on how do we really challenge ourselves, rise to the occasion, move away from current technology, current way of working into mission mode working on single common entities, which can seamlessly add on to the so-called theater that all of us are visualizing in the next 5 years. Rear Admiral Ajit, to you. Thank you, ladies and gentlemen.
Thank you very much, sir. It's a very esteemed audience which we have here, and many of them are colleagues in BEL whom I've worked with from my days as a lieutenant commander. So, BEL and other entities, you all generate the systems, and these systems have to work together on a ship. That's where an organization called VESI was founded in the late 70s, and we existed, that means more than 30 years. So we are Weapons Electronic System Engineering Establishment located at Delhi. So what we do is that we take systems from varied countries, and now of course all the Indian systems, and ensure that the systems work as one seamless entity on board the ship, and the ship interacts with other ships or the missions ashore to carry out a certain mission which has been given to it. Towards doing this, example, if you take a ship like say Nilgiri or Surat, which was recently commissioned by the Honorable Prime Minister, from the VESI side, we have a system integration group. We have around 150 types of interface protocols connecting up more than 35 different weapons and sensors on board. A lot of them are of BEL origin. That's there over the years, which is there. So integrating them together has been a forte for us. So you have one thing, you can keep making various interface protocols starting from resolver, synchros, today Ethernet, MIL standard. What we have done is, we have standardized some of these interface protocols over the years, and we have published them so that any startup or vendor, okay, a lot of them are startups out here. You come up with a certain product. The product has to, it's no use having a standalone product in the market today because it has to interact with something else. VESI comes into the role of taking this product and incorporating into the major system which is there on board. Now, since we are already dealing with huge entities like, say, Bharat Electronics, L&T, one of the roles we are looking upon is that a startup has got a life of, say, a couple of years. After that, you become an MSME and move on. Maybe some of the startups may move on to some niche areas. How does the service benefit and does get the guarantee that this technology is available to it? I think that is where entities like BEL and all come into play, because when you're dealing with organizations like VESI and BEL together, with VESI and BEL, we have a synergetic, we do work on niche technologies also. So the Chief of the Naval Staff set up a special task group recently with ACNS, FCI, and Admiral Raghuram and Admiral Bapna, which is there. So our theme was to look into some niche technology. So suppose you're a startup, you're offering some niche technology. We work with you, get you to a TRL, technology readiness level. That is also another important keyword which is important. You may be at TRL 1, 2, 3. Do I get into the act at that point in time? May not. It's too premature for me as an organization or say BEL to get into at TRL 1. Suppose we are able to work at say TRL level 5, 6 or 7. That's an area where say a production agency like BEL comes into play. VESI as an R&D organization which gets you inducted into the system, and together we induct the system, we do the proof of concept. One of the questions which was asked to the Chief of the Defense Staff was, how can we reduce the induction time of a system? That means I take this technology, put it inside an existing product which is already there on the ship, and then keep upgrading it out. One simple example I like to give at this point in time is, suppose you take a data link system which we are done with, again BEL as another example which is there. VESI makes the software, BEL gives the hardware, BEL provides the lifecycle support. A data link system cannot be saying that I made a data link system, now it should continue for next 10, 15 years like this. Communication sets are changing. We have the software-defined radios which have come into the loop which are there. Now, that means the link has to change. Do I wait for again qualifying it and again running through the full life cycle and wasting a year in updating it? No. We have got a much faster transition. Nearly every 6 months, you will find that an update is rolled out by VESI and BEL together, still following the normal cycle. That means a product which was inducted, maybe it may be an i3 processor or i4 processor at some point in time. We continue to support it. We continue to update the system, catering for the other systems which are fitted on board. When the hardware juice has been completely taken out, like you have a sugar cane, you put in additives and keep taking out the juice out of it. At a certain point in time, BEL pipes up and says, item is no longer supportable because the hardware obsolescence management cycle is there. Yes, the services then, the naval headquarters steps inside and upgrades it, maybe to an i7 or an i10 processor or something like that. So that is one of the processes which we said, you have technology, you induct it, and you keep upgrading it on the ship. That brings me to one moot point which is coming up of a DevSecOps environment which is there. Today, you are fighting a certain enemy of a certain nature. The enemy changes the way the Ukrainians, the drones are coming up. You got fiber optic drones. Now, we have developed a combat management system. Again, it is a VESI product with BEL Ghaziabad. We have developed it. A CMS has been given on board. I can't say, today I developed the system, took some 5 years to develop. In the 5th year or some 3rd, 5th year, when I'm inducting onto the ship, suddenly I find the threat has changed. Can I tell the user, no, I'm not going to give you any more features because the system requirement did not write it. It's of no use to him. So I have to upgrade it. So with a DevSecOps environment, we should be able to provide a regular update to the unit at sea in near real time or real time. So that means I have a development environment. I'm working with a developer. I do like you have a DevOps environment, which all of you are aware of in the software industry. The tester tests the equipment, then gives it, and then it is released. The release must be able to be pushed to the unit at sea. But again, the security is important. Suppose this process gets hacked. Some virus or something is injected. So that's why a DevSecOps environment is something which we would like to now dwell into with a major industry and see, can we get into this sort of stuff? When we move into the DevSec environment, we get into the concept of the communication suite, which is important. I'd like to just briefly dwell upon 1 minute in the tri-service level where we have delved into the communication. Communication is a key enabler for jointness today. The Indian SDR software standards and enabling framework, that is IS3EF, which is an HQIDS driven project which is there. It's like an Indian software communication architecture which is being evolved. What it does is that we are developing some common hardware variants of unhandled, man-pack, and some vehicle-mounted radios which are there. We have already developed some waveforms which are both voice and data. One secure voice and data, which all the 3 services can use among themselves. So that is the first step which we have gone for it. We are also developing some more MANET-capable waveforms. So what it provides is, it provides a high-speed, secure data connectivity between the 3 services. That's great, that takes care of the major stuff. You've got the drones which have come into the play. How do I ensure that my drone which I make, drones are available, everybody makes a drone. You'll see so many today in the Aero India. I would like to take this drone, incorporate it into my current system. That means I already have software-defined radios, which I've already inducted. In fact, Indian Navy is the first of the 3 services to have inducted indigenous SDRs, which BEL has productionized it. They're already inducted on all our ships. I can't say throw away this radio, I'll get another better radio after some time. The radio hardware has to be the same. That means the drones should be able to communicate to this radio which is on the ship. So I have to have a common waveform which I can port onto a small form factor radio, which we are in the process of developing with the Indian industry. And the same waveform must be ported on the SDR which is on the ship. So common set of waveforms which we are involved in developing. Excellent. The SDR we evolved it before COVID. It took a lot of time to get the SDRs into the thing. Now people are talking about cognitive radios. Great stuff. Now how can I just remove all these 200 radios which are getting inducted now? They're already entering Coast Guard also. So what we have done again with CRL Bangalore, we started working on it. Why not convert one of the channels of the current radio into a cognitive channel? So what are we doing? We are future-proofing ourselves so that we are a little bit ahead of the curve. One of the channels become cognitive, we can use it. Maybe the other channels will also become cognitive in future. So our radio is current. ATM technology came a lot of years back. When I did my MTech, ATM was the in thing. When I joined the naval headquarters, we were inducting it. I felt so nice, I knew some technology. My boss, I could give him good briefs on ATM. While I was in the naval headquarters for, say, 2 years, we found ATM is on its way out in the market and gigabit Ethernet is coming inside. We are just in the process of inducting these switches on a ship. You can't tell me that, I throw these out and get gigabit. So we had to start developing the gigabit technology at that point in time parallelly. So drawing that inference, coming to the software-defined radio side, while we are inducting these SDRs and all that, we also went into 4G LTE. We inducted them with IDEX challenge. 6G is going to come in the near future. Recent thing. So what we have done is we have got in touch with IIT Hyderabad. We started some projects with them. Can we take an OTFS waveform, develop it with the professors who are there, and maybe tomorrow this same waveform can be ported into the SDRs which we got. So we got the SDRs which came in. We have put a cognitive channel on it. We are also looking upon it. Can they be upgraded to having an OTFS 6G waveform which is there? Because 6G offers much more promises than 5G. So what have we done? We are future-proofing ourselves as communication technologies involved, because as CDS brought, we have to be ready to fight the war for tomorrow. Now you got a communication, you got a strong communication, encrypting communication. You have a drone in the air. Suppose somebody tries to jam your radio communication which is there. So one more project we have undertaken with IIT Chennai and the startups there is, can we encrypt this complete control channel for the drones? So the full communication suite consisting of small form factor radio, the SDRs future-proofing them, getting 6G is taken care of. Another requirement which comes up is, we have various agencies in India looking after coastal defense. And we have various foreign countries we like to collaborate with in a very easy to use manner. We came up with a product called Nishar, Network for Information Sharing. It's a simple use of internet with a server client architecture. We are able to just put it on the ship, use internet, put a high-end security on it using post-quantum crypto, and those are the product. Within 6 months, we were able to launch the product and keep updating it. The CDS saw the project and he says, I want a variant of it. So we came up with a SafeLink project that recently the Raksha Mantri launched. So slowly I'm turning the table from using pure military technology to start using commercial dual-use technology, incorporating it into the traditional stuff, and maybe getting it maintained by bigger PSUs who can provide the life cycle support. So what have we done? We are taking startups who can provide niche technology. We are taking well-established PSUs who are there. VESI as a system integrator, which is providing the service entity part of it, which Sir touched upon. How do we make use of officers and scientists who do MTech and they contribute to it? That brings me to two small technologies now is like AI and quantum. AI is like, if you have dal, you have to put tadka in it, and without tadka, dal doesn't taste nice. So if I say I'm not into AI, somebody will say you need to get out of this area. So any system we develop, whether it is combat management system, whether it is data link or anything, you have to put AI in it, and that is where we are working upon. Now, whether it is generative AI, whether it is computer vision. Example, we took an autonomous fast interceptor boat program. So you can just tell me when I'm coming. 2 minutes, yes, sir. We did a AFIB program which, when Sir was Director R&D, it was started off, and we're very proud to say it has reached level 4 autonomy. Sir. We needed certain computer vision tools. Seattle Bangalore with Inikai was working on a computer vision tool. We could take that product, incorporate it into the AFIB. Radar, we needed a radar, we needed a lidar. BEL had certain expertise of it, we could add on to it, sir. So we could make a normal fast interceptor boat into an autonomous boat using the expertise already available with organizations like BEL, VESI, and some startups which are there. The Indian Army saw this and they said, why don't you convert one of our boats and give it? At a certain location for the Army, we took one of their boats and converted and give it, and we are in the process of refining it out. So all this is happening within a few years or within a few months. We are able to use the technology available or the people available in the market and drive the stuff. So this is where we are looking upon. There are startups available here, agencies. They can work with established players and get the full process going. Nishar, which I mentioned, was one product which we developed. Somebody said that I need low-cost radars to be incorporated into the Nishar program so that we can give it. We have worked with some startups in Bangalore. We are getting a low-cost radar integrated into the Nishar program, which is there. Somebody said, I want drones to be incorporated into it, and I want to see the data on my mobile. Excellent, we are able to do it. So these, we are working within the confined frameworks of our induction process and able to induct these technologies which are there. And the last, I will touch upon quantum. Yes, quantum technology is important to us. We are working on quantum sensors and quantum positioning. But quantum computing, a question to be asked is, do I train my officers who are doing MTech in quantum computing? What is his employability today? May not be there. But maybe he starts doing minor projects, gets comfortable using it, and tomorrow when he's in a decently senior post, he knows how to take these decisions related to quantum. That is one place we are working upon using the officers which are there. Thank you, sir. I've covered all the areas which I wanted to cover upon. That was with respect to the. Thank you, sir.
How do we really handle the obsolescence of technology in this entire world where we are seeing avalanche of disruption happening every few years? So this is going to be a big challenge, and how do we really change our own mindset, especially in electronics, because we were very happy with maybe 100 nanometers, but today you're very greedy about 2 nanometers. And if a quantum processor comes, then again silicon architecture itself may go away. We really do not know. Optical fiber we thought was very great, but today you're looking at all kinds of application using optical fiber. It's a challenging scenario, but it's very good that very nice examples were brought out how Navy is trying to adopt in this scenario where you can actually do legacy technology and keep moving. We have another interesting panelist here, Dr. Subra, who does not need any introduction to the Indian aerospace community. He's a PhD from Indian Institute of Science, but then he joined ISRO and did some phenomenal work in structures. In fact, he's considered as one of the fathers of composite technology. And then at a later date, he went on and started a wonderful industry. Today, not just they in fact build satellites right here in Bangalore. And he's actually one of the source of inspiration for all the scientists who want to become entrepreneurs at some point in time in their life. And very aptly, he has named his firm as Anant Technologies. You know, Anant to me really looks like the way we are heading, because we have actually now invented probably close to 100 odd exoplanets, which means that we are going to move out of the solar system soon in the years to come. May I have the pleasure of inviting Dr. Subrao to share his thoughts. Dr. Subrao, please.
Namaskar to everybody. As Professor Jagdish has said, the very name apt, that Anant, the company's name is Space Technology. Anant is infinity, infinity is space technology. That's how the space technology come into that. That's why Anant Technologies in that. But anyway, now, General Reddy Garu and CDS spoke extensively about the theater and the technologies part. And when you look at those things, I think there's nothing much left out to talk about the technology part of it. But only the point here is, can we find the space technology in each one of them? Yes, in each one of those activities which they have planned, either in theater or in any other technologies. For example, the hypersonic technology which the professor has explained just now, every one of that requires the satellite connectivity. That means space is going to play a major role everywhere in our life. In fact, in a societal way, if we start in the early morning, we start with look at the Panchanga, or the position of the planets, and what's the auspicious time, what's the good time, bad time, everything. I think that's all. That means the space has become the part of each one of us in every aspect of that. And how do we bring in for the technologies for the defense and the other related to conflicts into that part? Now, as in the beginning, as Mr. Toby has mentioned about, for future conflicts, what's going to be done, how the space technology can be made use of on that. I think if you look at our adversaries around us, we can see them with many satellites in their orbit, looking for India, every nook and corner of India on that. That means what we are lacking today is complete surveillance, what in our terms called ISR, that intelligence, surveillance, and reconnaissance. This part is completely absent from our side in terms of building a constellation of satellites today. We don't have it today, but we will have it in future. I'm sure that very soon, in a couple of years, we start having the constellations start building up into that part. And these constellations are going to be the most important for our theater wars and also any future conflicts on this. And space, you see, as far as the technologies are concerned, we have all the technologies available for the space in this country itself on that. You must have seen that, from the ISRO side, we are on the moon, and we had the docking experiment that we have successfully done on that in the space, and we also went to the Mars, and we also many other programs going to that means we have many other technologies that we have already in this place. Now, the specific technology that required for the space, for the defense side, from space, what are they required, how to reorient them towards that. That's where academics, Professor Jagdisha, and the industry like us, and the requirements from the defense side, we have to put them together into it. And now, in order to do this part of it, what kind of see, we are talking about 2047 to be Vikasita Bharat, and we are talking about Atmanirbhar right now and that. In fact, in the space technologies, we have Atmanirbharata. In most of the cases, already we have it more than 90% of that. Perhaps the defense technologies, we lack there completely on that. And whatever is our Ajit has mentioned just now about the communication side, the communication platforms to upgrade them, doing it part of it. The basic problem is most of the platforms are coming from abroad. And to update them, there's something like, black box in that. So that's where we should bring the Atmanirbhar completely from the very, very beginning into that and see that, we get the complete technologies on that. After all, we study the same textbooks that Westerns have studied, and we have the same equipment what Westerns have that. So what else is required? We have better brains than them. We can do a much better job on that. So I'm sure that, the space technologies, its utility can be made use of the defense sector very extensively on that. But one thing is the audit system that what we have within the defense, that has to undergo something change. Some change towards Vikasita Bharat of this country. What were the British of implementing into the academic systems and the audit system, that should go away from that. That's what we look forward onto that, and we require a lot of support from the defense in order to achieve more and more onto that. Instead of my making it a monologue with you, I would like to engage all of you, because each one of you is a distinguished in your own fields, would like to engage with you in kind of a discussion further on that. Perhaps, a dialogue would be much better than my speaking into that, because we are already 12:30, one more session also there, and one more session with Jay Jagannatha is going to be something very interesting on that, on the lasers and other things in that. So, any questions, anything in the space-related part of it, we'll be happy to engage you into that, with the permission of the chair.
The Q&A is at the end, so we'll just finish the panels and then we'll have the Q&A.
I think probably they're going to take questions at the end. Just to wrap up, I think all the three panelists, we are on the same track in some sense. I think there is enough space for defense, and there is defense for space. Ownership of next generation technology at every level is extremely critical for us to move ahead. And let me thank the panelists and also the audience for patient listening. Thank you very much for the opportunity. I hand it over to MC.
A heartfelt thank you to our esteemed panelists, Professor Gopal and Jagdish, Dr. Subba Rao, and Rear Admiral Ajit Dedappa, for your insightful contributions to this discussion. Your expertise and perspective have provided a valuable takeaway for all of us. We also extend a special thank you mention to Professor Jagdish for moderating this session. I now request Mrs. Neeti Pandit to kindly join me on stage to hand over a token of our appreciation to all the speakers. To Professor Gopal and Jagdish. To Dr. Subba Rao. And to Rear Admiral Ajit. Thank you. For our next session, we have another set of distinguished panelists, and I request them to join me on stage as I call out their names. Our first panelist for the session is Dr. Jagannath Nayak, Distinguished Scientist at the Defense Research and Development Program, DRDO, Hyderabad. Our second panelist is Mr. Parithi Govardhanraju, CEO, Okulu. And our third panelist is Mr. Manoj Palmer, founder, Aethon Tech. I request the speakers to please join me on stage. Dr. Jagannath Nayak will also be the moderator for the session. Over to you, sir.
Distinguished guest, all the invite over here, ladies and gentlemen, very good afternoon to all. And sorry that my throat is not permitted to speak more. First of all, let me thank BEL, CMD BEL is here, Manoj Kumar Saab, and Synergy Foundation Chief Simon Saab is here. Thanks, they have invited me to be part of very challenging section. I can say in Aero India, it is the most challenging section because we are now talking about the future, but none of your friends are going to help for your future. Neither neighbor, anybody. You have to decide your future, and for that, you have to first of all become Atmanirbhar. Self-reliance is going to be the key to start the foundation of the future. So for that, we have three distinguished panelists with us. Since my throat is not permitting, I will take very less time. So my suggestion is that we will speak 5 minutes each, and or 7 minutes, and then we'll leave to the audience to ask the question. So I am going to talk about the directed energy weapon system. And as you know, it is very, very interesting to see this Star Wars movie. And when I was also young, that time I saw the Mr. India movie also. So that time I was thinking that whatever this is shown, is it going to be happen? Can Anil Kapoor vanish one day? And then reappear as he wish. So similarly, I am going to present a Star Wars and Mr. India type of technology where it is a reality. In India, we made it, and we have not depend upon anybody. And this is made in India. It is manufactured by none other than our friend BEL. CMD BEL is here. 25 units we have manufactured. We have also deployed in different strategic locations, and this is a short story. But while thinking about future, preparing about the future, and whatever the different roadblocks we face and we make that technology, that is just in a very short time, 5 minutes I'll talk. Can you help me or I have to help myself? In those people, most of the people now, the directed energy weapon, who is holding a pistol, he knows what is directed energy weapon. So in that cases, I need not to tell anything, but I want to say, this is not emerging. I'll say new weapon system. Other countries have taken into the field, and we have also taken into the field. We have not got this weapon from outside, but we made ourselves where other people have denied. So that is the stage now. And as you know, this is the weapon is going to be invisible. It is not going to produce any sound. You must have killed anybody, nobody knows it is killed. It is just like sleeping. Something happened, heart attack, something, but it is died. So this is the type of weapon. And we also talk about, my friends are here, artificial intelligence, they are talking, but I can tell during my lifetime, say, while giving a talk, using direct energy weapon, I'm sitting over here, border the direct energy weapon is operated. We are not going to require to go to the field. We are going to sit down in a theater, we are going to sit down in a AC room, and we will operate the weapon. And we are going to use that type of, that is the direct energy weapon. Rest of the thing are physics and chemistry, but for that, you require concentrate of the beam. They say SIBA. Wherever you want to take your hand, the SIBA hand is nothing but an antenna and a laser mirror. Just you fold your mirror, direct it is become destroyed. So that is the SIBA. That is nothing. This is what is there. Direct energy weapon is nothing but SIBA in different form of the wavelength, microwave, light, particle physics. These three are the SIBA, three forms of the SIBA. And is a laser, it is a microwave, and it is a high energy particle wave. That is the SIBA form. And the rest of the things I can say, at present, whatever the direct energy weapons are available, they can do very short range air defense application. You are not required to fire thousands number of missiles like our CMD was saying, not required to fire. You exhaust their all kite with this weapon and ready keep the missiles at the last end game. Then you have also at the border there are many things you are throwing, rocket, artillery motors, you can also depend. Anti-drone system is 100% success. You can dazzle the satellite. You are not required to fire against satellite and make the space friends is sitting, not to make the space a clean place where you fire the laser, blind them. Do not allow them to do anything. Then at the end, if they are going to fire a nuclear loaded missile, you destroy it into their boost page. So these are the interesting facts. So I again want to tell that advantage is enormous. So one thing I just want to say, that you want to kill a human being, just take that laser beam, put into where heart is located. Not required to put, no bleeding, nothing. And low cost, 1 liter of petrol, 1 missile, 1 aircraft is destroyed. 1 liter of petrol. Invisible, I told, and infinite time of firing you can do. So deep magazine, and you can recharge. Many advantages are there, but all the application, whatever I talk, everybody agreed. But only one thing that now they disagree, that in the booster phase, whether you are able to do that missile. All other applications are tried. So what you require is a powerful laser, starting from 1 watt to kilowatt and megawatt. 3 applications. You want to kill a UAV, you require 1 to 10 kilowatt of laser. Fine pointing with 1 microradian accuracy. You require a RAM or a missile, you fire 100 kilowatt of laser, and ballistic missile you require 1 megawatt of the laser. So if you are going to have 1 megawatt class of the laser, then you are able to try to do all the kind of defense. You do not require missile, but as I said, I spent 25 years of my career in the missile complex. I love missile, but I say it is not only laser, it is laser plus missile is required for our country. I'll take it out. A lot of work is there to do the development. So it affects the atmosphere. You have to study the lethality, many things. The laser is the key. 4 types of lasers are there: gas laser, liquid laser, fiber laser, and all kind of laser with kilowatt power we are developing, indigenously developed, and indigenous developed lasers are being used for our application. And BEL is the key player for all our weaponry. And this is what happened. We may be telling these are the challenges when you are going to take a coastal belt. 8 kilometers is the distance. The laser beam start dancing, but you are going to control it. There are many methodologies to control. This is one methodology we have done. This is what is tested at Balaswar. Then you see that how you are going to stabilize a beam at a few kilometer distance with micro-radian accuracy. Left side is one of the practical place where we have put the beam and is rotating the arm. With micro-radian accuracy, we have a fine point. Right side, you see that aircraft model is there. The laser beam is scanned. Where you want to put, you can put. And rightmost, we have a drone. We have destroyed the laser beam. We simulate the condition that taking the cue, and it went and hit to the bottom part of the drone where it was carrying the explosive, but the drone was alive, it was working. If we want to use to kill, that is how the drone, this is one of the part we did. At chase, as I told you, this is the center where we develop the system. We are not the alone. In the country, near about 14 number of R&D institute, academic institute, international collaborator, and industry partner, everybody works for that technology. We have made 5 class of DW, 10 technology developed, 5 number of LATOT we have done, and 4 patent also, international patent we got. And whatever I was showing, this is also one of the anti-drone system. It is manufactured, technology transfer to BEL and 4 more industry. They are manufacturing numbers now. And these are the media item. I can say this is what is put into the media. And where are we now? As I said that when US president is visiting and our anti-drone system is guarding US president, that is where we are now. It is not that US president when visit to India, this is our anti-drone system put into Ahmedabad, that cricket stadium. That is our strength. And we have all versions, development, ground, ship, airspace, and all airborne. And microwave also similarly we are also progressing. It is going to be the wide area network. Because of time, I will just leave it at it. And this is a particle wave. This is going to be really not going to kill, it is going to destroy physically the part. And between missile and DW, I say that they are all complementing, but battlefield, both weapon system is going to be there. Thank you very much. Now I invite my panelists to express their views. As my throat is not permitting.
Good afternoon, everyone, esteemed officers, defense professionals, and strategic stickers. It's an honor to speak on a technology that is to set to revolutionize modern warfare. So today I'll briefly touch on how hypersonic technology could affect modern warfare and ISR operations. Professor Jagadish in his previous talk briefly introduced the subject, so I'll not delve much on the technology, but on its applications and how it could change the paradigm of modern warfare. So, as everybody has been seeing the warfare evolve over the last 4 to 5 years, specifically in Ukraine and before that in the Armenia war and recently in the Gaza conflict, it's evolving at a very rapid pace where asymmetric technologies like drone warfare, hypersonics, technologies such as AI, cyber warfare, and are shaping the future of battlefields. So, hypersonic warfare, as Professor Jagdish also defined, is something that flies at speeds exceeding Mach 5. And because of the rapid speeds, the ability to react to such adversarial threats is limited. And this changes how battlefields will evolve in the future. The unmatched speed and maneuverability poses a strategic risk to other defenses which have not evolved. So one of the core tenets of modern warfare is to improve or accelerate the OODA loop. So the OODA loop stands for Observe, Orient, Decide, and Act. We at Akula Aerospace are looking at technologies which improve the observation and the orientation, where we are developing persistent ISR systems. And then you have hypersonic technologies which rapidly reduce the OODA loop, where the adversary has only hours or maybe even minutes to respond to a threat. And because of their ability to go at very high speeds and also maneuverable, unlike ballistic missiles in the past, hypersonics and hypersonic glide vehicles can maneuver in midair and go to a specific target. The precision strike capability is unmatched, and it can lead to lethal damages, which current systems are not equipped to defend. They can also penetrate advanced air defense systems. So there's a need to develop a multi-tiered defense network or a defense architecture where observation or detection of these hypersonics should happen at 3,000 or 4,000 kilometers away, and then you have multiple systems to counter hypersonics. And it's also from a theater command perspective, it is essential the integration of the hypersonics happens within the next decade. With theater command structure, hypersonics will provide a rapid first strike capability in multi-domain operations across land, sea, and air. This is very crucial, as first strike ability where that penetrates to various defense systems will give a unparalleled advantage that can shape the results of war. In India, with the evolution of theater command, we have the northern theater, which is China focused, and the western theater, which is Pakistan focused. Establishment of certain hypersonic missile centers that are dedicated to these commands would prove crucial in the years to go. Hypersonic missiles can also be mobile and can be available on submarines and naval warships, which helps us to dominate the Indian Ocean region. So if we look at hypersonic development over the last decade in India, specifically you have the hypersonic test demonstrator vehicle that was demonstrated by DRDO in the 2020s, where they demonstrated speeds up to Mach 4. With further developments happening in India and abroad, we can see hypersonic vehicles get to Mach 7 and Mach 8. And because of the extreme kinetic energy that these systems generate, in addition to the detonation and explosives, they have unparalleled precision strike capabilities. We also have the BrahMos 2 missiles that are being developed, which are predicted to operate at Mach 7 plus. And investing in hypersonic glide vehicles is essential for long-range deterrence, and strengthening collaboration with various ecosystem partners and stakeholders ranging from academia, startups, mid and large-scale industries, and of course the end user is crucial for achieving this dream. Of course, countering hypersonic threats demands a comprehensive and layered approach. We need advanced sensor networks, both in space and terrestrial, and even in near space operations. As General Chauhan alluded to earlier today, the need for persisting monitoring systems to detect these kind of threats, either in space or in near space, is essential. So the development of persistent aerial systems like HAPS, which are high altitude pseudosatellites, and space-based detection systems is important to detect these threats much earlier and take adequate countermeasures. And effective integration requires a holistic strategy where ISR systems need to provide real-time sensor data for essential of the tracking and targeting these hypersonic threats. We also should develop adequate C2 systems, command and control modernization, to manage the compressed timelines that are posed by hypersonic warfare. And the development of data commands allows for the joint force interoperability, where a single decision maker can look at all the information gathered and decide on the next course of action. This informational superiority that we gain from persistent monitoring systems and the ability to respond to certain threats using hypersonic missiles would be a game changer for the next few decades. As you see, we are not the only nation that are looking at hypersonic technologies. The US has been looking at it for more than 2 decades. The Chinese, of course, has demonstrated a few weapons recently. And the US recently increased its budget for hypersonics and persistent monitoring systems from about 4 to 5 billion to about 10 billion. And it's essential that we also put adequate thought and effort and the resources needed to develop this technology. It's mere improbable that any of our allies would be willing to give this or on a transfer of technology. It's essential that we develop this indigenously. So to conclude, hypersonic technology and persistent monitoring systems are not merely an evolution in warfare, but a revolution in military affairs. Our ability to integrate these systems into data commands will define our strategic advantage in the coming decades. And continued investment, development, and a collaborative approach is an essential to ensure our readiness. Thank you. Jai Hind.
Good afternoon, Jai Hind. My name is Manoj, and I am a co-founder of an AI Tech. Many of the esteemed colleagues before me have talked about very important topics about the future of conflicts and other things. And many of us believe that the history repeats itself. What I want to correct that statement is that the historic patterns repeat itself. And the foresight is all about looking from that historic pattern and applying them in the current context. I want to use this lens to say that how the warfare has evolved. At the initial days of a warfare, if you really see that the ground forces and superior artillery ruled the world, it transitioned when the globalization kind of nothing happened, it transitioned into the naval forces. The superior naval forces ruled the roost. Then came the air force. It entirely changed the phenomena, and the superior air forces used to rule the things. And then came the different kind of phenomena, where it is no longer the superior ground forces, the naval forces, or the armed forces. It's all about the superior technology or superior weapons with a limited kind of resources. They started ruling it. And then we entered into suddenly the newer era, where it's no longer only the weapons, it's the information system which has started ruling the roost. And today what we are seeing is that all of that information system is now metamorphing itself into the AI revolutions. So now where we are coming to, we have come from ground forces to the naval forces, to the air forces, to the weapon systems, to the information systems, and to the intelligence. This is the one parallel. Another parallel that I want to draw from the historic pattern is that in initial days, it was all about the intelligence topic, right? Intelligence and counterintelligence, which is done by the humans. Later on, it evolved into the information warfare. And then it has evolved now recently into the cyber warfare. Going forward, it is again going to be the intelligence warfare, but it is no longer the human-based intelligence warfare. It's going to be the artificial intelligence-based warfare. This is where the world is moving towards. And it is very clear today, right? The China and US race is to to essentially demonstrate who builds a better AI and who has a better control. Recently, if you have heard the news that the OpenAI has already made an announcement to work within a DoD on a very specific AI-related topics. This was for the in the US. On the Europe, there is a company called Helsing, which has now done an alliance with an Mistral to use the generative AI technologies in this. And China has its own entire ecosystem as well, right? So what we are seeing is that the future of conflict is going into the artificial intelligence, and this is the new fault line. The question is that then should we use it, like how everybody is rapidly using it, or are there certain issues? Obviously, there are other issues of structural issues like the data, the compute, and other things. But one of the key concerns which always comes when it has to go into the mission critical system is that, can I trust this technology? Because as history has also shown that as and when any technology comes up, in general, there are always going to be some kind of vulnerabilities with that. And every new technology that brings in new vulnerabilities gets exploited. One very important anecdote that I want to give it from the historical thing is from the information warfare was the German Enigma machine. It was a perfect machine for confidentiality preservation. It gave the superior advantage, and it continued to remain there until and unless the Polish breakers with the UK guys broke that code. What happened with this precise movement is that the entire system's fundamental assumption that the confidentiality is given was violated. Now, what it means for the AI is a very important aspect. What happens if the AI's confidentiality is violated? What happens if AI's integrity is violated? What happens if AI's availability is violated? I had a different kind of a presentation for today where I was supposed to use the AI on my mobile and just do the interactions. But here when I come and I see that the network is not there. Zero availability. What we can do? Superior technology, but can't use it. Similarly, there is we were just discussing with Rear Admiral Ajit here on one of the use case where to identify the ship in the ocean from satellite data or from the visual things. What if I can tell you that I have a technology which can cloak that ship for AI, not from the human eyes, from the AI? The integrity of the entire system is violated. Your fundamental promise that I can do the scanning at a scale and identify that this ship belongs to the enemy, gone. Entire advantage is gone. Integrity is gone. Confidentiality, another aspect. What if you have developed an AI with lot of your proprietary data and everything, and if this AI I can recreate, your entire advantage is wiped out. All superior advantage with respect to the data has gone into the AI, and if I am able to reproduce, the entire system's confidentiality is wiped out. You no longer have a superior advantage. These are the real challenges on the field that needs to be addressed. And I'm not speaking hypothetically. For all the three cases, which I talked about, the confidentiality, integrity, availability, there are real cases which are happening. In the Ukraine warfare, Russia painted just the planes onto the runway, like runway here, just painted the planes. Most advanced ISR technologies, computer vision-based technologies, detected that there were planes until and unless the fusion happened. What was the fusion? The satellite did the thermal scanning after 5 days. And when they tried to look at it, the thermal scanning only picked up 1, the visual had in the 3, so for the 5 days, everyone was thinking that there are 3 planes on that particular runway. Artificially boosting the things. It's a classic decoy tactic which RAF used against Luftwaffe during that entire invasion thing. Other side, same Russia hit the plane from all the ISR and satellites by just putting a tire on top of that. Rubber. That's it. We think about such a sophisticated technologies and sophisticated ways to do the attack and defense. In reality, when the technology meets the reality, it is very, very brittle. That's why it takes a lot of time to perfect it. And this is where the future of conflict and technology alignment is all about having go into that rapid adoption and improvement kind of in a loop. Another thing with respect to confidentiality, for an example, Chinese startup has recently released the DeepSeek R1, which is a generative AI, which many of you have heard about. We have just done the interrogation of it to identify all of the PLS technology because that is the only generative AI model has ever seen the Chinese restricted data set. I don't have to enter the China. I can interrogate the AI models to get all of the confidential information out of it. It's a new form of a counter intelligence and counter espionage which is going on. I just want to highlight all of these cases and say that the AI is a force multiplier and it needs to be adopted. But the key remains is that I think I will use your metaphor with, that all of this 4 quadrant that you have done. With the AI, known risks are known, that is, it is inaccurate. But what is unknown? What if somebody figures out that black swan event and makes the entire things go? We have seen this kind of things. Iraq's invasion was all about the WMD, which was the false information. One satellite picked up something wrong, which was interpreted it's a weapon of mass destruction, and it's happened. We don't want to live into the world where we have the superior technology and we have put a lot of effort to build them, put a lot of effort to deploy them, but we can't use it from practical and usability point of view. And this is where the security of the AI-related system is a very, very paramount topic, that we don't have to only think about the AI's functionality, but also the security aspect, that can I secure this AI because it's an asset class. With this, I just want to leave this floor for all of you to think about it. How can you secure the AI system? Thank you.
Thank you to all the speakers. On account of time, we're not able to do a Q&A session on stage, but you can always catch them outside and have a conversation with them. On that note, can I invite Mrs. Neeti Pandit and Ms. Samrita Shetty to felicitate our speakers with the token of our appreciation. To Dr. Jagannath Nayak. To Mr. Pariti Govindaraju. And to Mr. Manoj Palmer. On that note, I would like to hand it over to Mrs. Neeti Pandit to give us our closing remarks.
Good afternoon. On behalf of BEL and Synergia, I would like to propose the vote of thanks on this occasion to the esteemed gathering. Shri Manoj Jain, CMD BEL, Lieutenant General GAV Reddy, Deputy Chief IDS and DG DI, eminent speakers, senior officers of the armed forces, dignitaries from the industries, R&D organizations, academia, startups, members of media, ladies and gentlemen. At the outset, I would like to express a sincere thanks and deep sense of gratitude to General Chauhan, though he's not there now, Chief of CDS, for his august presence during the seminar and his deep insights to the future of warfare, basically highlighting technology drives tactics and tactics drive technology. Sincere thanks to our CMD, Shri Manoj Jain, who has decades of experience and has contributed immensely to defense R&D and innovation for the country, for sharing his thoughts on the emerging technologies, significant role to be played by startups and R&D community with active support of Indian industry for offering comprehensive solutions to the armed forces preparedness for future warfare. He also brought out the futuristic technologies being developed by BEL, both in-house and collaboration with national R&D organizations, startups, academia, in the field of unmanned system, direct energy weapon systems, cyber warfare, guidance system for next generation missiles, cognitive technologies, quantum computing, etc., and BEL's unwavering support for indigenous R&D. Thank you, sir. We also place on record our appreciation for Lieutenant General GAV Reddy, former Deputy Chief IDS, DG DIA, for his profound views on the technological disruptions, asymmetrical threats, and the organization structure of the armed forces to have a competitive advantage over the adversaries to face the future conflicts and achieve its goals. Thank you, sir. And I would also like to thank all our panel speakers, a deep sense of appreciation and gratitude to all of you for conducting the sessions professionally with their immense knowledge and expertise in their respective domains and their foresightedness on the emerging technologies, asymmetric threats, which has given the participants different perspectives of the opportunities, uncertainties, and challenges, and the need for collaboration, greater synergy to meet the requirements of the armed forces to face future warfare. Thank you, sir. And I would also like to thank all the participants for their support and sharing their views. We thank each one of the participants. Finally, I would also like to thank MOD, the organizers, Synergia Foundation, and all other stakeholders and individuals who have supported directly and indirectly for the successful conduct of the event. Thank you, one and all. And I also take this opportunity to highlight some of the niche products and systems on display at Aero India by BEL. I would like to invite all of you to BEL stall that is in Seminar Hall E, where we have also displayed the theater command and many more products like direct energy weapon, EW suit sensors, weapon systems, and so on. Thank you.